Use logarithmic differentiation. Alright folks, in this video we're going to introduce logarithmic differentiation and go over one of the applications of it. But before we do that, I just want to review our properties of logarithms. I know we did just review them in the previous video, but we're going to be using them again here. So, if we have log of some base b, or a natural log, this works for too, and the inside is multiplication, we can pull apart multiplication on the inside to be addition on the outside. So the log base b of m times n is equal to log base b of m plus log base b of n. And then if we have log base b of m over n, if we have division inside the log, we can separate it and pull it apart so the subtraction of the numerator minus the denominator. So log base b of m over n is equal to log base b of m minus log base b of n. And then finally, our third one, we have log base b of m to some exponent. We can bring that exponent down to the front as a coefficient to make it become x times log base b of m. And again, while I wrote log base b here, it also works for log base e, which is our natural log. So these three properties work for regular logs and for natural logs. Alright, so now what is logarithmic differentiation? Logarithmic differentiation is a method that we can use to help us take derivatives of complicated functions. Now I'm sure you thought that all the functions we've been taking derivatives of are complicated, which maybe to some extent they are. However, the ones we're going to review in this video are even more complicated, so get ready. Alright, so what are the two main uses, or the two main types of problems we're going to see in this course where we're going to use logarithmic differentiation? Well, the first one is when we just want to avoid using the product rule, or the quotient rule, or a combination of both, the product rule and the quotient rule. And an example would be something like so. So if we want to take the derivative of the quantity x cubed minus 1 to the fourth times the square root of 3x minus 1 all over x squared plus 4. That is a chain rule and a product rule and another chain rule all rolled into a quotient rule, so that is a lot of work right there. So we could use logarithmic differentiation here to simplify that process down. It might be a little bit more work, as in more steps, but the process will be simpler than having to use the multiple chain rules in the product rule and the quotient rule. And then the next type of question that we would encounter in this course that we could use logarithmic differentiation for, or at least the ones that we're going to go over right now, is when we have a variable in both the base and the exponent of a function. So for example, if we have f of x is equal to 5x raised to the 9x power. So if you notice, we have a x in the base and an x in the exponent, and we really have no idea how to take the derivative of that yet. We probably have never seen anything where there's an x in the base and an x in the exponent. But good news! With logarithmic differentiation, you can derive those functions. Alright folks, let's take a look at our first example. So here we're told if f of x is equal to x raised to the x power, we want to find f prime of x. So basically we want to take the derivative of x to the x power. Now this is called logarithmic differentiation, and this is one of the forms that we need to use logarithmic differentiation for, because this is a complicated function. X in the base, x in the exponent. So our first step is to take the natural log of both sides of our equation. So we're going to take the natural log of both sides. Now, why do we want to take the natural log of both sides for this particular problem? Well, because we don't like having a variable in the base and in the exponent. So we want to somehow move a variable either out of the base, or we want to move a variable out of the exponent. With natural logarithms or regular logarithms, they allow us to move an exponent out of the exponent and down to the base. So that's the key here, and that's why we use logarithms in order to move the exponent out of the exponent down to the base. So what does that leave us with? That leaves us with a natural log of f of x equals x times the natural log of x. And now we can take the derivative. So we know the derivative of natural log of x is going to be 1 over f of x times the derivative of the inside. And that equals, and now we have x times the natural log of x, again, times being the all-important term here, meaning product rule. So the derivative of x is 1, and that's times the natural log of x, plus x times the derivative of natural log of x, which is 1 over x. All the calculus is done now, so let's dive into the algebra. F prime of x over f of x is going to be equal to the natural log of x plus 1, because this x and that x will cancel out. And then same thing as before, we want to get the f prime by itself, so in order to do that, we need to multiply both sides by f of x, and when we do that, this f of x, that f of x will cancel out, leaving us with f prime of x is equal to the natural log of x plus 1 times f of x. But just like before, we know what f of x is. F of x is x to the f, x. So we can substitute that in. So we get the quantity natural log of x plus 1 times x to the xth power. And we are finished. So it's something as simple as this one. It isn't going to take much work. However, these problems tend to get a little bit more complicated, and will, get more complicated at a slower pace. For example, we want to take the derivative of 5x raised to the 9x. So just a tad more difficult here, but same process. Take the natural log of both sides, bring the exponent down to the coefficient, differentiate both sides, get the f prime of x by itself, substitute the f of x back in, bing, bam, boom, done. Let's do it. So again, first step is we want to take the natural log of both sides. And then natural log allows us to bring the exponent down to the coefficient, giving us a function, the natural log of f of x is equal to 9x times the natural log of 5x, and if we're looking ahead, we see there's going to be a product rule there. So we can go ahead and take the derivative. So 1 over f of x times f prime of x is equal to, now we have to do the product rule. Product rule says the derivative of the first, which is 9, times the second, which is the natural log of 5x, plus the first, 9x, times the derivative of the second, which is going to be 1 over the inside, which is 5x, times the derivative of the inside, which is 5. Now, calculus is done. Let's continue simplifying. F prime of x all over f of x is equal to 9 natural log of 5x plus, let's see, 9x times 1 over 5x times 5 is going to be 45x over 5x. So we can simplify this. F prime of x all over f of x is equal to 9 times the natural log of 5x plus 9, because 45 divided by 5 is 9, x divided by x is 1. Good, done. Let's get the f of x, or f prime of x, by itself. So again, we'll multiply both sides by f of x, with our f of x's on our left canceling out, leaving us with f prime of x is equal to the quantity 9 natural log of 5x plus 9 times f of x. And again, we know what f of x is, so we can substitute that in. So we're going to get 9 natural log of 5x plus 9 times 5x to the 9x power. And we are finished with that problem too. So now let's just get a little bit more challenging here. So what if we have like a trig function in the exponent? We still would use logarithmic differentiation because we still have a variable in the base and a variable inside the exponent. Same thing happens. Natural log of both sides, bada 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 bada, and we're done. Let's do it. So we're going to have the natural log of f of x is equal to the natural log of x raised to the sine of x power. And we can bring the sine of x now down to the coefficient, giving us the natural log of f of x is equal to sine of x times natural log of x. And wouldn't you know it, there's a product rule again. Starting to notice a pattern? I hope so. All right, now calculus time. Let's take the derivative. 1 over f of x times f prime of x is equal to cosine of x natural log of x plus sine of x times 1 over x. Remember, product rule. And then we're going to simplify as much as we can. Not much simplifying can be done here, but we will have f prime of x over f of x equals cosine of x times the natural log of x. I don't know how that dash underneath there, how that got there. How do I get rid of that? Probably just should have erased it, but again, I hit the undo button to get all the way back there. Bad decision. Alright, so again, leaving us with cosine of x times the natural log of x plus sine of x divided by x. And then just like every other problem we have done in these videos, we want to get the f prime by itself, so we're going to multiply both sides by f of x. And what does that leave us with? Well, that's going to leave us with f prime of x is equal to the quantity cosine of x times natural log of x plus sine of x over x times f of x. But again, we know what f of x is, so we can substitute it in. I've run out a little bit of room, so I'm going to write it up here. So f prime of x is going to equal the quantity cosine of x natural log of x plus sine of x over x, and that is times x to the sine of x power, and there is your derivative. Alright, one more problem to go, and then you have learned logarithmic differentiation. And now we get on to the complicated problem. So if f of x is equal to the quantity 2x to the fourth plus 1, all raised to the tangent power, find the derivative. Nothing changes except this looks a little scarier, but again, same process. First, take the natural log of both sides. We want to get that exponent to be a coefficient. So we have the natural log of 2x to the fourth plus 1, all raised to the tangent of x power. Now that we have the natural logs on both sides, we can bring the tangent at the front and look at that product rule again. Hope you're getting good at the product rule. And this is going to equal tangent of x times the natural log of 2x to the fourth plus 1. Alright, algebra's done. Calculus time, let's take the derivative. 1 over f of x times f prime of x, and we are going to need that product rule there. So the derivative of tangent is secant squared of x times the natural log of 2x to the fourth plus 1 plus tangent of x times 1 over 2x to the fourth plus 1 times the derivative of that, which is going to be 8x cubed. And now we can simplify. F prime of x all over f of x is going to equal secant squared of x natural log of 2x to the fourth plus 1 plus 8x cubed tangent of x all over 2x to the fourth plus 1. And then, just like always before, we want to multiply both sides by f of x to get the f prime by itself. So what's that going to leave us with? Well, it's going to leave us with the answer. What's the answer? F prime of x is equal to the quantity secant squared of x times natural log of 2x to the fourth plus 1 plus 8x cubed tangent of x all over 2x to the fourth plus 1. And I'm going to kind of skip a step here because this is like the third or fourth time we have done this. Instead of writing times f of x, I'm actually just going to multiply it by f of x, which is 2x to the fourth plus 1 raised to the tangent of x power. And there we have it. Logarithmic differentiation, folks. If you have any questions, please let me know. Office hours, email, Canvas message, homing pigeon, your choice, and I'll see you in class next time.